Take a look around your home right now. In your kitchen, there is probably a glass bottle holding water or juice. In your bathroom, a roll of toilet paper sits quietly beside you. A bar of soap rests near the sink. Somewhere in a drawer, a roll of aluminum foil waits to be used. These objects are so common that we rarely notice them. They are part of our daily rhythm, woven into our habits so naturally that we never stop to ask where they came from. But here's something most people never think about. Before these simple items reached your hands, they passed through roaring furnaces, massive industrial rollers, chemical reactions, and precision-controlled factories running day and night. Behind every everyday product is a world of heat, pressure, science, and human expertise working in perfect coordination. These objects may look ordinary, but their creation is anything but simple. Today, we are stepping inside the hidden world of manufacturing to uncover how glass bottles, toilet paper, soap bars, and aluminum foil are made. And once you understand the process behind them, you will never see these everyday items the same way again. 1. Glass bottles, born from fire and sand. A glass bottle feels smooth, solid, and almost timeless. Yet its journey begins with something surprisingly basic: sand. The primary ingredient in glass is silica sand, combined with soda ash and limestone. These raw materials are carefully measured and mixed before being poured into massive industrial furnaces. Inside these furnaces, temperatures rise above 1,500 degrees Celsius. At this extreme heat, the mixture melts into a glowing, molten liquid that looks like flowing lava. This molten glass must be handled with extraordinary precision. It is cut into measured portions called gobs, and each glowing gob drops into a mold. Compressed air is then injected into the mold, shaping the molten glass into the form of a bottle. This process is known as blow molding, and it happens in seconds. However, shaping is only part of the story. The newly formed bottles are still extremely hot and fragile. They move into a controlled cooling chamber called an annealing oven. Here, the temperature is gradually reduced to relieve internal stress and strengthen the glass. If this cooling process is rushed, the bottle can crack or shatter. After cooling, each bottle passes through strict quality inspections. Cameras and sensors check for cracks, thickness, consistency, and shape accuracy. Even a small imperfection can cause rejection. Only bottles that meet precise standards move forward for packaging. What seems like a simple container is actually the result of extreme heat, advanced molding technology, and precise thermal control. From sand to solid transparency, a glass bottle is truly born from fire. 2. Toilet paper. Softness engineered with precision. Toilet paper may appear to be one of the simplest products in the world, yet its manufacturing process is surprisingly complex and highly engineered. The journey begins with wood pulp or recycled paper materials. Logs are stripped of bark and broken down into tiny chips. These chips are cooked under pressure with chemicals to separate the cellulose fibers from lignin, the natural glue that holds wood together. What remains is a soft pulp mixture. This pulp is washed, cleaned, and sometimes bleached to achieve the desired whiteness. Then it is mixed with large amounts of water and sprayed onto wide moving screens. As water drains away, a thin mat of fibers begins to form. This delicate sheet passes through heated rollers that dry it rapidly while preserving softness. To some, toilet paper is embossed during this stage, where patterns are pressed into the surface. These patterns are not just decorative, they improve softness and absorption by increasing surface area. The dried sheet is then wound into massive rolls that can be several meters wide. These giant rolls are later cut into smaller rolls using high-speed machines. Each roll is precisely measured to ensure consistent sheet length and thickness. Finally, the rolls are wrapped, packaged, and prepared for distribution. What feels soft and lightweight in your hand has passed through heavy industrial machinery, chemical processing, and precision engineering to achieve the perfect balance of strength and comfort. 3. Soap bars. The chemistry of clean. A simple bar of soap sits quietly by your sink, yet its creation is rooted in chemistry that dates back thousands of years. Modern soap production begins with oils or fats, which can come from plant-based sources like palm or coconut oil, or from animal fats. These oils are combined with a strong alkaline solution, typically sodium hydroxide. When mixed under controlled conditions, a chemical reaction called saponification occurs. This reaction transforms oils into soap and glycerin. In large industrial kettles, the mixture is heated and carefully monitored to ensure complete reaction. Once the base soap mixture is formed, additional ingredients such as fragrances, moisturizers, and colorants may be added to enhance the product. The soap mixture is then cooled and dried until it becomes solid enough to process further. It is fed into machines that extrude it into long, continuous bars. These bars are cut into individual pieces with precision blades. Next comes stamping, where each bar is pressed with branding details using heavy molds. This stage not only shapes the soap, but also compresses it to increase durability. Before packaging, bars are inspected for uniformity in size, texture, and appearance. The result is a product that feels smooth and gentle, but has undergone controlled chemical reactions, heating, molding, and shaping processes. That small bar beside your sink represents centuries of chemical understanding combined with modern manufacturing efficiency. 4. Aluminum foil, strength rolled to perfection. Aluminum foil may look thin and delicate, yet its production involves immense force and industrial precision. The journey begins with bauxite ore, which is refined into alumina and then smelted to produce pure aluminum. This aluminum is cast into large rectangular slabs. These slabs are heated and passed through massive rolling mills. Each pass through the rollers compresses the metal further, reducing its thickness step by step. The process requires extraordinary pressure and precise control to prevent tearing. As the aluminum becomes thinner, it is rolled together in double layers to achieve extremely fine thickness without breaking. After rolling, the sheets are separated, leaving one side shiny and the other slightly matte. The foil is then trimmed, inspected, and wound into large rolls. Machines cut and package the foil into consumer-sized rolls ready for kitchens around the world. Despite its thin appearance, aluminum foil retains remarkable strength, flexibility, and heat resistance due to the rolling process that aligns its internal structure. What feels fragile is actually engineered for durability and performance. Glass bottles formed in roaring furnaces. Toilet paper engineered for softness and strength. Soap bars created through controlled chemical reactions. Aluminum foils shaped under enormous industrial pressure. These are not just everyday objects. They are the result of science, engineering, chemistry, and human dedication working together behind the scenes. Factories operate continuously to maintain precision. Engineers refine processes to reduce waste and improve quality. Workers monitor production lines to ensure consistency. The next time you hold a glass bottle, tear a sheet of toilet paper, wash your hands with soap, or wrap food in aluminum foil, pause for a moment. Remember that behind that simple object lies a hidden world of innovation and effort. Understanding how everyday things are made changes the way we see the world. It reveals that even the most ordinary items carry extraordinary stories within them. And once you begin to notice those stories, you start to see daily life not as routine, but as a masterpiece of human ingenuity quietly unfolding around you.